Okay, example number 5. Oops. So we're looking to find the integral of exponent or exponential, sorry, to the power of x times sine x. Okay, so let's write that. We'll have the integral of e to the x times sine x dx, right? Okay, so what we're going to do for this problem is we're going to use IBP or integration by parts. So let's write what that is. Integration by parts, lines, parts, or sometimes people call it IBP. Okay, so integration by parts. Let's see, that's if you have u dv, you can rewrite this as u times v minus the integral of v times du. And sometimes this is done because it's easier to take the integral of v than it is to take the integral of u. So we're just rewriting it so it might be easier to compute. All right, so let's try to apply this to what we have. So what we're going to do is we're going to designate some values as u and some values as v so we can replicate this integration by parts formula. All right, so let's let e to the power of x equal to u, and let's let sine x dv, or sorry, dx equal to dv. Okay, so I kind of wrote them backwards because it's not the way that you're used to seeing it, but if we take the derivative of this first term here, the u term, let's do du by dx. Well, what's the derivative of e to the power of x? Well, e to the power of x, it's always just the same since x is, there's nothing in the exponential, it's just x. So the derivative of the exponential is just itself. What we're going to do here is move the dx to the other side. And you'll see why when we have to substitute it in the equation for the integral above. So yeah, move that to the other side, and that's ready to use for IBP. So for this sine x dx term, for the exponential term that we just did, we took the derivative. But for the sine x term, we're going to take the integral so that we can see what the not integrated version looks like, okay? So we're taking the integral both sides. We know that the integral of sine x dx is negative cosine x plus c, some constant, and that is equal to v because the integral of dv is just v. Okay, so this constant here, I'm just going to leave out for now, out of the equation when I sub it in. You'll see in a second. I'm just going to leave that out because we're going to add it in later. It might get in the way, so it's a little bit confusing if you leave it in, but we definitely have to make sure to include it later. Okay, you'll see what I mean in a second. So let's sub things in for integrating by parts. Okay, so starting from the same first equation, we have e to the x times sine x dx. Okay, let's if that is the u by dv portion, then let's write what u times v is. So u is e to the x. I'm just going to underline things as I go. Okay, so e to the x is u times v. This is v. We have minus cos x plus c, which I said we're going to leave out for now. How much am I blocking here? Oh, just the IVP. Okay. And then, zooming out a little bit, we have minus the integral of v. V we just saw is minus cos x times du. Okay? Du we calculated to be e to the x dx. All right, so now you kind of understand why I needed to take the derivative and why I needed to take the integral, right? Because they were useful when we were subbing them in for integration by parts. Okay, so now that we have this, I'm just going to simplify it slightly so that we get rid of all these brackets. I just left them there so you could see which parts were U and which parts were V. We don't need them right now. So actually the minus cancels out, so we have plus the integral of cos x e to the x dx. Okay, so now you can kind of see, well, we're kind of back to square one, right? We still don't know what the integral of cos x e to the power of x is. It's kind of almost the same thing as what we had originally. So that means what we're going to have to do is apply integration by parts again. All right, so I'm going to do the same thing as first time, and we're going to let u equal to something else now. So we're just focusing on this portion, right? Because this first term is now integrated. We don't have to worry about it anymore. We're just working with the second term. Okay, so we're going to let u equal to the same thing as before, e to the x, so this term here, and we're grouping the cos x and the dx, even though they're not next to each other. We're going to group those together, right, for dv. dv, whoops, is equal to cos x dx. Okay. So we're going to do the same thing as we did before. We took the derivative of du by dx, equal sign, equals to e to the x, because remember, the derivative of the exponential function is just itself, and we're just going to move that dx over again, really just the same as last time. And for the dv term, the cos x dx, we're going to integrate again. So we get v is equal to, well, the integral of cos x is sine x. And we have a plus c term. Like I said, leaving that out for now, but we will come back to that and add that in later. All right, so now we can sub it back into for this part above. Let me write the whole thing again. So we have dx sine x dx is equal to minus cos x, because remember the first term stays the same because we're done integrating with that. But we have this whole second term that we need to write. So we have plus, okay. So now applying integration by parts. It's all the way up there. Hopefully you can still see that. Okay, so if we have u times dv, we're going to have u times v out in front. So u is e to the x times v, just sine x in this case. Remember, just leave out the plus c for later, unless you want to keep that in. That's up to you. And then the integral of v, that's the sine x. Running out of room here, right in the corner. Hopefully that's still clear. At times, where are we? Times du. Okay, du was e to the x dx. All right, close that big bracket there. Okay, now we're going to just simplify and well, why did I change that? Here we go. Minus cos x e to the x plus, I'm just rewriting without all these extra brackets so that it's easy to see, minus sine x. Well, actually, I'm going to change the order of this. So we have minus exponential x times sine x dx. Well, if you notice, you actually have something pretty cool here. We have this term and this term, which is the same term on both sides of the equation. Now this one's being subtracted, this one's being added, so we can't cancel them out. But what we can do is we can move this term on the right-hand side of the equation to the other side of the equation, right? So we can do that just by adding them, or adding this term to both sides. So that's what I'm going to do. And when you add this term to the other side, you actually get 2 times the integral of e to the x times sine x dx. And then the minus cos x e to the x plus e to the x sine x. And there we go. So as you can see, on the left-hand side, we have the integral that we are trying to figure out. And on the right-hand side, we don't have any more integrals. So it's a solution, right? So let's divide both sides by 2. The whole thing there is divided by 2. So we get that the integral of e to the x sine x dx is equal to minus cos x e to the x divided by 2 plus e to the x sine x divided by 2. Okay, and we can't forget our plus c from before. That's the only thing. I didn't include it before up here. Oops, sorry, too far. I didn't include it here when I added it into the equation. I didn't include it in the second step when I added it to the equation. I didn't want it to get in the way, but if we did add it, we would have had to add it to the right-hand side of the equation. So I'm just adding that in now, the plus c. And remember this constant, this plus c, it can be added or divided by 2 or anything like that, and it's still c, it's still a constant, right? Because a constant divided by 2 is still a constant number, okay? So, yep, don't forget to add that, either if you want to add it in before or add it in at the end. And this is our final answer. So, might be kind of an unexpected way to get to this answer, but that's how you do it. So that's how we found the integral of that equation. So these are the answers. Just going to put this solution is correct, and we can compare to see that it's the same thing. I just have the cos and the exponential swapped, right? All right, that's it.